Welcome to All This Math. This is Professor Parker, and today's lesson, we're going to talk about simple interest word problems. Simple interest word problems. So this is also an attempt to show how getting rid of math classes in schools is not the solution to the problem, right? Because you need math, you need algebra, you need pre-calculus, you need calculus, you need statistics in order to perform personal finance. So we can't just substitute personal finance for math, right? We need math as a tool to be used in order to solve personal finance problems and answer personal finance questions. All right, so it's a both and thing. It's not an either or thing. All right. Also, if you go to any math textbook, you'll find personal finance word problems in the textbook. So one of the issues is, how do we as teachers better provide application support? You know, education and instructional around applications of the math that's being taught, of the formulas, of the equations, and all the different processes and topics that are being taught. How do we then do a better job of applying that to personal finance? And this is an example of a personal finance word problem where you're going to see how we need to know how to do algebra in order to solve personal finance problems. All right, so the actual problem is printed in the description underneath of the video. Hopefully you are subscribed to the channel and you have the post notifications turned on. All right, the problem reads as this. Reginald had $15,000 invested, and that's a nod to Baltimore native Reginald F. Lewis, who was a successful businessman and also has a museum named in his honor in the city of Baltimore, the Reginald F. Lewis Museum. They have a lot of quality programming that takes place there on a regular basis. So anyway, Reginald had $15,000 invested in two accounts, not one, but two accounts, two separate accounts. One is paying 9% simple interest, and one is paying 10% simple interest. First thing is, in a real life scenario, you'd much rather be receiving compound interest, right? You much rather be receiving compound interest, but that's another conversation. But just recognize that when you read this problem. How much was invested in each account if the interest after 1 year is $1,432? So when we deal with simple interest, we deal with a formula. This is our simple interest formula. We have capital I is equal to PRT. Capital I is the interest amount, the amount of interest that's earned on the investment. Capital P represents the principal. The principal is the original amount of money invested or deposited, okay? R stands for the interest rate that's applied to the investment, that principal, and T is the amount of time that is taking place, all right, in order for this interest amount to be accumulated. Now, he has two separate investments. So we can't just use the formula one time if he's got two separate investments. So let's break it down like this. Let's do investment one and investment two. Let's just call it investment one and investment two. So this is how I'm gonna set them up. Set them up like this. I sub one is investment one. We got P for the principal. Now we don't know what the principal is. The problem does not explicitly tell us what the original investment was in each of the individual investments. That's what we have to figure out. So for now, we're just gonna use the variable P. But we do know for the first investment, the interest rate was 9% because it says one paying 9% simple interest. That means that the interest rate was 9%. So we're going to show multiplication because PRT means P times R times T. There's no multiplication signs in between, but they don't have to be. If you have letters written like that, that indicates multiplication in math language. This means P times R times T. But we're going to replace the letters with numbers. All right, so R is 9%, but we're going to rewrite that as a non-percentage value. So what you do is you take 9 and you divide by 100. I'm gonna say it again. When you want to convert a percentage to a non-percentage value, take 9, take that number, divide by 100. 9 divided by 100 is 0.09. So this is gonna be 0.09. And T is the amount of time. If we read the problem carefully, it says if the interest after 1 year, not 2 years, not 3 years, not 6 months. It says 1 year. It explicitly says 1 year. So then you replace the T with a 1. So this is information, this is some of the information we need for our first investment. Then we go to the second investment. The second investment, we still don't know the principal of that because we don't know how much, because it was 15 grand basically. 15 grand was invested in two separate accounts. We don't know if it's 10 in one and 5 in the other. We don't know if it's 14,000 in one and 1,000 in the other. We don't know if it's 8,000 in one and 7,000 in the other. But we know it was 15 grand total altogether. Altogether, with both investments combined, we had a total of a certain amount of, actually no, right here, the P. The P was 15,000. The I was 1432, right? So, but we don't know individually how much the principals are. We're going to deal with that in a moment. So we changed 10% into 0.10. And you don't really need the zero, but I just put it there just because it was 10%. I like to keep things consistent to an extent. And it's still after 1 year. So this is our investment 1 is the principal times 0.09 times 1. Investment 2 is its principal times 0.10 times 1, right? Now we got to do something about these principals. So we're going to figure out what are we going to call principal 1 and what are we going to call principal 2. All right, so principal 1, we have no idea what it is. So therefore, we're going to do some algebra. And this is what I was talking about earlier. We got to know how to do this. This is personal finance. We're doing personal finance right now, right? But we need to do algebra in order to do personal finance. All right, so keep that in mind. So the issue is the solution to the problem is not to get rid of the math. The solution to the problem is to show young people how the math applies to personal finance. Because at some point, you're going to hit a wall. Now, unless you just want people just sitting up here that are successful at personal finance and have all these answers about personal finance just preaching to you, right? Like you just sitting there listening like it's a spectator sport. If you want the students to be able to get their hands dirty and really do some problems and do some math and do some calculations on their own, they're going to have to know algebra. There's no way around it, right? Now, you can say, okay, well, it's a computer program. They can plug these numbers in. Yeah, okay. That's true. But wouldn't you like for them to understand what it is, what's behind the work within those computer programs? What the calculator is actually doing? What the formula calculator on Google is actually doing? Wouldn't you like for them to know that so they can better understand it? So anyway, the first principle, let's say we don't know it. So let's just call it X. Let's call it X because we don't know it. We don't know what it is. So we're going to call it X. Like I said, we don't know if it's 14,000 and the other one is 1,000. We don't know if it's 13,000 and the other one is 2,000. We don't know. We just know it's a total principal of 15,000. That's how much was invested, split between these two investments. Now, so if the first one was X, how can we represent the second one? Now, this is a key issue in mathematics, a key issue in algebra. We have to know how to represent the second one. If there's a total of $15,000 and this first principal, we're calling that X, the second one would be 15,000 minus this one. In this case, X. So it would be 15,000 minus X. That's what that would be. So the principal from the first investment is X. The principal from the second investment is 15,000 minus X. Because think about it. Hypothetically speaking, I want to make sure this makes sense to you. Why this is valid and why this is valid and this is valid. Let's say hypothetically that the split was like, I don't know, 14,000 and 1,000, right? So if X is 14,000, right, the other investment would be 1,000. But isn't 15,000 minus 14,000 equal to 1,000? It is. So that's why this expression is a good expression. You take the total amount and subtract the other amount, and that leaves you with the amount of the second investment, right? Same thing if it was 8,000 and 7,000, 8,000 and 7,000, right? If this is 8,000 and you do 15,000 minus 8,000, that leaves you with 7,000. So the second investment would have to be 7,000, right? So whenever you encounter this type of situation, when you got a total amount of something and you pick a variable to represent one of those items, and you know the total amount. You don't know the individual amounts of each of those parts, but you know the total amount. You make X one of them, like I did here, and you do the total amount minus X to represent the other one. That's just something for you to memorize whenever you see a word problem and it's set up like this, all right? So now what I can do is I'm going to set up another equation, right? Because actually, let's do this. Let's do I total. Because the total is going to be this PRT plus this PRT. This PRT plus this PRT. right? Because remember, it's two investments. It's two investments. It's two investment accounts. So if you add them together, you get the total amount of interest. And the problem talks about the total amount of interest, which is $1,432, right? So we're going to have this plus this. So the principal of this one is going to be, now let me put this in brackets, X times 0.09 times 1 plus 15,000 minus X. I'm going to say 15K. K stands for 1,000, right? 15K minus X times 0.10 times 1. So take a moment and just look at this equation and make sure it makes sense to you. Because all I did was I took the first investment, I1, and combined it with the second investment, I2. This plus this. Investment 1 plus investment 2. Investment 1 plus investment 2 should be equal to the total amount of interest. And the total amount of interest is $1,432. Our goal is to solve for X, because once we solve for X, we'll know the value of the principal, the original investment on the first investment, and then we'll be able to figure out the investment on the other one, because we're just going to do 15 racks minus however much was invested in the first one. All right. So now let's replace this with 1432. So we got 1432 is equal to, now let's clean this up. 0.09 times 1 times X is just 0.09X. All of that simplifies to just that. Multiplication is commutative. It don't matter the order that you do the multiplication in. 0.09 times 1 is just 0.09. 0.09 times X is 0.09X. Then over here, we're going to do, this is going to be 0.1. Then we have to multiply or distribute, because this is going to be 0.10. I put a slash through it because I rewrite it as just 0.10, because 0.10 times 1 is just 0.10, because we just multiplying by 1. Now I got to distribute this times this. So 15,000 times 0.1, right? Basically, I'm taking 10% of 15,000, which is 1,500, right? So this is going to be, let me see, 1,500, right? Minus 0.1x. Where did the 0.1x come from? 0.1 times x. And it's negative. Negative x times 0.1 is negative 0.1x. 0.1 times 15,000 is 1,500. All right. Now what I'm going to do is I'm going to combine like terms. So I got 1432 is equal to, now 0.09 minus 0.1. 0.09 minus 0.1 is going to be negative 0.01. Negative 0.01x. See these combined. This is like 9 cents. That's a dime. So 9 cents minus a dime is a negative penny. Basically, 9 cents, 0.09, right? This is not 90 cents. 0.09 is 9 cents. 0.1 is 10 cents. 0.09 is 9 cents. 0.1 is 10 cents. Because 0.1 is the same thing as 0.10. That's 10 cents, right? Combine the terms. Negative 9 cents, well, actually positive 9 cents minus a dime leaves you with a negative penny, 0.01. All right. And then we still got plus 1,500. I want to isolate this, so I got to get rid of this. I get rid of this by doing the opposite operation. Opposite operation is subtraction. So I'm going to subtract 1,500 on the right side. I got to stay balanced like Mayat, ancient Kemet, and all that. And then I'm going to subtract 1,500 on the left side also. Cancel them out because that's 0. And that's what I wanted to happen. So 1432 minus 1,500 is going to be negative. Let me see. What's that? 70. Let me see. It would be. Is that 70? 68. Negative 68 is equal to negative 0.01x. Negative 68 is equal to negative 0.01x. I'm trying to get x by itself now. I got to get rid of this negative 0.01. I do the opposite operation. The opposite of this multiplication is division. So I divide by the same exact number. So I'm going to divide by negative 0.01 on the right side. I divide by negative 0.01 on the left side. Boom, boom. That equals 1x. That's 1, and that's x. So that's x. So that's negative 68. divided by negative 0.01, which is going to give me 6,800. Negative 6,800. So if the principal from the first investment was $6,800, then what's the principal from the second investment? 15,000 minus the 6,800. So 15,000 minus 6,000 is going to be 9,000. And then 9,000 take away the 800 is going to be 8,200. So it's $8,200. So this is like, so when students say things like, I don't need to know all that, I don't need to learn all that, all I need to know how to do is count my money. All right. I want you to be able to count your money. This is how you count your money, by doing algebra. So if you can't do this, I don't know how you're going to count your money. Because you give somebody your 15,000, say you go give somebody your 15,000, right? Your hard-earned money, or maybe it wasn't hard-earned, but still it's your money, right? You give it to them and they invest it for you. And they tell you like, yo, you get your investment back and it's like your money not looking right. Your number's not looking right. But you can't, you feel some type of way, but you can't substantiate your claim, right? You just feel some type of way. You can't back it up with math, right? Because all you want to do is know how to count your money, right? So you let somebody else do the math, but you just want to count your money after they give it to you. You don't want to verify if the money is right. You don't want to learn none of that, right? All right. Hope that works out for you. So look, 6,800 in the first investment, 8,200 in the second investment, but we shouldn't stop here. We should make sure that it's correct. So we got to go back in and make sure that 1432 is in fact equal to 6,800 times this plus 8,200 times this. So let's check over here. 1432 is equal to 6,800 times 0.09 times 1, because the time is 1, but we don't got to put that because it's just multiplied by 1 anyway, plus 8,200 times 0.10. So 1432 is equal to, this is $612. And this is $820. Because you multiply by 10%. So you just slide the decimal point over one space. That's just like dividing by, you know what I'm saying? Dividing by 10 also. Multiplying by 1/10 or 0.10. So the question is 1432 equal to 612 plus 820? And it is. Because 600 plus 800 is 1,400. 12 plus 20 is 32. So that's 1432. Boom. That's proof that it's right. So you don't want to just like do math and then like get the answer and then just stop, right? You always want to check your work if you have time. Unless you want to standardize test or something, then maybe, you might want to just go into the next question. But whenever possible, always check your work. Verify that it's the truth. Because another value of math, besides the problem solving ability that it helps you develop for yourself, is that it helps you to find the truth. Now, this is the truth. 1,432 is the same as, that's what the equal sign means. It is the same as 1,432. It is, right? No doubt. You can stand on that, right? But these are the numbers that give you the truth. The 6,800 and the 8,200. So that's how you know that these are the correct answers, because the correct answers give us the truth. And that's what we're really looking for. We're looking for the truth. And that's what math does. Math gives us the truth. All right. Also, before I go, shout out to Tennessee State University in Nashville, Tennessee. And shout out to all the HBCUs. All right. Now, I showed you this. Now you got to go get some practice. Go practice some word problems, solving some word problems that include the interest equals principal times rate times time formula. All right. Practice. You got to practice. All right. Because again, you want to be able to count your money, right? This is how you count your money. This is how you count your money. You got to be able to do these types of problems. And remember, also, you don't want to get rid of algebra because you need the algebra to do the personal finance. Wait till we get into compound interest. Like, how you gonna do compound interest problems with no algebra? You can't do work with exponents and all that. Like, you can't, multiply and all that type. Yeah. Understand this. You need algebra for personal finance. So if it's personal finance that you want, that's cool. You should understand personal finance, but understand the tools that are required in order to actually do that. Don't get caught up in the hype and a lot of the popular conversations that are just coming from frustration. I understand it. I dig it. I get it. I used to be there. I've been there before. I understand the frustration, but don't let the frustration have you leading people astray and even limiting yourself in your own learning. All right. So go get some practice, and I'll see you in the next video. Peace.